Hello, everyone. My name is Ricardo Lourenço. I'm starting my third year at the University of Chicago at the Computer Science Department, doing my PhD. This work is done together with Elizabeth Moyer in the Geophysics Department and Ian Foster, who is my advisor. So basically, I came here to talk about clouds. That bugs most of this audience here, but for me, it's my object of study. Specifically, these ones here, which are the stratocumulus part of clouds. The thing that we are interested in this problem is that clouds play a major role in the uncertainty of our climate models, basically because we can't necessarily determine the amount of reflectivity that we have in certain regions, and stratocumulus is a major example of that. So, and basically this impacts a lot of the radiation balance that's getting to those regions. So when we look to our cloud classification models, basically they just have two axes in terms of like being thick or thin and low or high cloud. And this doesn't necessarily represent the previous complexity that I've shown before. So what we have right now with Google Earth Engine is a very large catalog of data, and also, we're talking about MODIS and Landsat with hundreds of terabytes, even petascale data, but we are basically underutilizing it with the current methods of classification. Using Earth Engine and doing regular cloud segmentation algorithms, if we invert that, we can obtain segmented clouds that are free for us, but on a scalable way. So I did that, and basically we input data, and from those data we start sampling, and we feed a convolutional autoencoder for one cloud class type, let's say stratocumulus, and we start to iterate over several epochs. And by the end, we want to find a compact form that perhaps reveals a pattern of that cloud that's representative. If it's agreeing with the major dominant pattern, it's okay. We look in the literature and we validate. If it's from another class, okay, also it's misclassification. But what we find a new pattern that wasn't described. Is this a new cloud class? So this is what we are looking for. We hope to have geoscience feedback on this classification. And our results that we get from this model is when we apply inference on this source data, we are able to have better, smoother results at the end. Right now, we are somehow extending for inversion using the Lucid library and scaling up to run on supercomputing. I'm open to questions. Thank you.
Any questions? All right. Thank you very much.
One in the back.
Oh.
Brian? What things are you excited about being able to do on supercomputers versus Earth Engine?
Our idea on that is like pulling out data, doing the preprocessing on Earth Engine, and then ingesting for training on supercomputer, but with a very long time series. Probably using Horovod for that and Cray API, probably. But we're still defining architecture for that.
Also, big graph analysis and hypergraph analysis.
Yeah. This is like in the long term.
Yeah. Thank you.
Thank you very much.